Figure 1 shows a central vertical cross-section of the design for a solid glass ornament. And Figure 2 shows the finite region R, which is bounded by the y-axis, the horizontal line CB, the vertical line BA, and the curve AO. And this is the ornaments formed by rotating the region R through 360 degrees about the y-axis. So we've got a volume of revolution to consider. And AO, just this bottom bit, is modeled by this equation down here. K is a constant, and then we know that A is on that part of the curve, so we can use that to find K. And that's the first thing we're asked for. So I'm going to sub in for 0.4, which is going to equal 16K plus 2. And then we can rearrange that. Minus 1.6 is going to be 16K, so K is equal to minus 0.1. Use algebraic integration to determine the exact volume of glass that would be required to make the ornament according to the model. So I'm going to split this into two parts. We've got the curve, which we're going to need to consider carefully, use integration for, and I've got this bit at the top, which is actually just a cylinder. So I can see I'm going from 4 to 4.5. So we've got a cylinder with a height of 0.5, and this volume 1 is therefore going to be pi r squared. And this distance here is 0.4, so pi times 0.4 squared multiplied by the height, pi r squared h. And that ends up being 2 over 25 pi. Then we've got volume 2 to deal with. So volume 2, we've got little cylinder created, and that is going to have a width, a radius of x. And then to get the area of a cylinder, it's going to be pi x squared for this infinitesimal little cylinder. And it's got height dy. We're going to sum all of these up, and that is what the integration is doing. So this is the volume of our revolution along the y-axis. And I'm going between 0 and 4. So I'm going to get, remember I've got k is minus 0.1, so it's minus 0.1 y squared plus y to the half all squared dy. This is a double bracket member, so I think I might just make it a little bit clear my solution. Write this. So I'm going to get 0.01y to the 4. And deal with this bit now, plus y. And then it'll be minus 0.1 y squared times y to the half. That'll become y to the 5 over 2. And I've got another one of them that's actually become 0.2 here. I haven't integrated yet. I've just expanded the bracket, so we're now ready to integrate. So I'll get 0.01 divided by 5 times y to the 5 plus a half y squared minus, this would be y to the 7 over 2, and then it's going to be 0.2 times 2/7. And then just work this out in the calculator, and you should get 2,392 over 875 pi. When you put a 0 in, it's going to get 0. So just put the 4 in really carefully. And therefore, the volume is going to be V1 plus V2, which is our 2 over 25 pi. It does ask for it to be exact. Let me just remind you about that. Plus 2,392 over 875 pi, which becomes 2,462 over 875 pi. Data limitation, the model, there's quite a few things you could say here. I said that ornament may not be perfectly symmetrical, which we have assumed. Okay, other things you could say are that the equation may not be suitable, sides of the ornament might not be perfectly smooth, could be flaws within the glass, and that corner at the very top might not be a perfect right angle. There's other answers you could say, just as long as you can kind of, critique it in some way. Then finally, we're asked, or we're told, when the ornament was manufactured, 9 centimeters cubed of glass was required. Use this information in your answer to B to evaluate the model explaining your reasoning. So V, which we've just worked out, if you put that in your calculator and get it to some decimal places, is actually 8.8395. So we've got to compare that with 9. And the easiest thing to do is just say, look, it's very close to 9. So model is suitable. 1 mark for the comparison, and the second mark to say it's suitable. Now, there are other things you could say. So you could actually say the model volume is less, so not enough glass will be ordered. That's quite an interesting take on it. So it's a bad model. You could start talking about what is a good model and what's a bad model. It was a little bit subjective. You could talk about the percentage error and so on, but just some kind of sensible comment regarding like making a comparison, and you'll be all right. Well done.